Hello, we will pick up from where we left off on the notes. I was working on page 8 from the notes packet. So if you can just turn to page 8, we had done the first transformation. This is the second one. I made you guys write down the parent and the transformation, but we did not do the graph. So let's go ahead and do that. So we can see that this is a square root. So let's, like I always said, that let's do the parent square root before we do the transformation. So remember, square root of 1 is 1, but we start the vertex at 0, and then square root of 1 is 1. And then next we jump to 4, because square root of 4 is a whole number. So we want that. So 1, 2, 3, 4, 1, 2. So don't forget, you want to draw this as a dotted line, so you see how the parent function looks like and how it is getting transformed. The only two transformations taking place are 4 units to the left. So 1, 2, 3, 4, and 3 units down. 1, 2, 3. So this is my new vertex, and there's nothing else. There's no reflection, there's no vertical stretch or compression. So you're going to construct the graph the same way that you're doing did the parent. So 1 across is 1, and then what did we do for the next point? We did 4 across, because remember it's square root, so you want square root of x, so square root of 4. So from here 1, 2, 3, 4, 1, 2. So this is my new one. This is the dark line. This is my new graph. Yeah, so my parent, my transformed graph. Okay, let's go ahead and write the domain and range. So domain, I can see that it only starts from -4, right? Is it -4? Yeah, 1, 2, 3, 4. And -4 is included, and it's going on forever. And as far as range is concerned, it's starting at 3. Right? Sorry, -3. I'm sorry, -3. This is -3. And remember, it's wide, it's going up. There's no restriction, so this will be infinity. -3 is included, so I want my square brackets. Let's go ahead and write the limit. The limit, okay, so this limit is not infinity. It's going towards, so this is x, going towards -4 from the positive side. Because this is not a graph that's going on forever on both sides. So because of that, they've changed the limit on the positive side. So there's -4 here. And if you come from the positive side, so if I kind of draw this line here, and if I come from the positive side, and the minute I reach -4, what is the y value? The y value is, can everybody see? It's -3. So it's -3. So you remember, you're reading the y value for when it reaches that particular x value, and that's what limit means. And as x is going towards, this is just x is going towards infinity. As x is going towards infinity, my y value is slowly increasing. It's slow, but it is increasing. So it's going positive infinity. Alright, moving on to the next one. So my parent here is square. So y equals to x squared. Let's see the transformations taking place. There is a reflection over x-axis. And then 3 units to, it's -3, so it will move forward. And 2 units up. Everybody good? So x -3, so it's 3 units forward and 2 units up. Okay, so let's go ahead and first of all do the parent really quick. Parent is parabola, so vertex is here, 1, 1, and 1, 2. 2 square is 4, 1, 2, 3, 4. 2 squared, -2 squared is also 4. Dotted line, because it's the parent, it's not the actual graph. And now let's do the transformation. My transformations are going to be, first you move the vertex. So vertex is 1, 2, 3. No, I'm sorry, I'm moving forward. I'm so sorry. 1, 2, 3, and 2 units up. 1, 2. And there's no vertical stretch or compression, so I don't have to count that, but I do have to go down. So going up, because there's a negative. So 1 across, instead of 1 up, it goes down. 1 across is 1 down, and then 2 across is 4 down. 1, 2, 3, 4. And 2 across is 4 down. So my actual graph looks like this. And my let's go ahead and look at domain and range. So remember, domain, it's going on forever in both directions. Even though it doesn't look like it, it will cover all the negative x values, and it will cover all the positive x values. So it's negative infinity, positive infinity. Let's look at the range. It starts with negative infinity, but it does stop at positive 2. So it starts with negative infinity and stops at 2, and 2 is included, so I put a square bracket. Let's go ahead and do the limit. X going towards negative infinity, and this one is x is going towards infinity. So as x is going towards negative infinity, what's happening to my graph? My graph is falling down, so it will be negative infinity. And as x is going towards positive infinity, what's happening to my graph? It's falling down. Remember, you're reading the y value, so it's also negative infinity. In this, you have both of them will go in the same direction. The end behavior is in the same direction. Either it goes up or goes down, depending on if there's a reflection. And the last one for this page is transformation. First of all, okay, parent. Parent is a cube, so y equals x cubed. What are the transformations taking place? Reflection over x-axis, 1 unit forward because it's negative 1, and 2 units up. Sort of similar to this, except you want to be constructing a cubic function. So how does a cubic function look like? Vertex is here. Vertex is here, and then excuse me. And then, so you move 1 cube is 1, and negative 1 cube is negative 1. And then the next perfect cube is at 8, so what you do is you go 2 cubed, you climb up to 8. 1, 2, 3, 4, 5, 6, 7. So somewhere here. And negative 2 cubed is negative 8, so somewhere here. So my graph will look like, remember what I said, like a snake going up and down. And then let's go ahead and look at the domain and range. It's going on forever on both sides, right? Because it's slowly expanding. It may look like a straight line, but it's not. It's slowly expanding. So negative infinity to positive infinity, and definitely so for the range. And then as x is going towards, I'm doing the end behavior. Limits x is going towards negative infinity. What's happening to my graph? The graph is falling down on the y-axis. So it's going to be towards infinity, right? So negative infinity. And then as x is going towards positive infinity, so unlike in a parabola where the end behavior is on the same side, but both up, open down, this one will be going, the end behavior is in the opposite direction. Okay, we'll stop this video for now. You have one more video to watch, which will be equally short.